Hello everyone. In this video, we are going to discuss the solutions of power electronics questions which are given in recently conducted exam, that is AEE in the TSPSC. This exam was conducted on recent January 2023. Now let us see the first question. Consider the following statements about a phase controlled single phase full bridge converter using SCRs. That means there are 4 thyristors in a given bridge. 3 statements are given in the question. We need to select which of the above statement is true. Now if you go to one by one statement, the average output voltage at the DC side varies linearly with the firing angle. Suppose if you look into, now let me write down, this is about a statement A. Average output voltage, what is the expression for single phase full converter? 2 Vm by pi cos alpha. So it is mentioned that average output voltage at the DC side varies linearly with the firing angle, but it is not linear relation, it is a cosinusoidally. Therefore, I can say statement 1 is not correct. Next, second statement. The power factor at the AC input side depends on the converter firing angle. This statement is true because if you look into input power factor for a rectifier circuit, we will always measure the power factor at the input side. Input power factor formula is 2 root 2 by pi multiplied with cos alpha. That means power factor of the rectifier circuit, single phase full converter, it depends on the firing angle, and hence second statement is true. Second statement is true. Now the third statement, the converter cannot be operated with firing angle greater than 90 degree. This statement is not true because if alpha is greater than 90 degree, single phase full converter can be operated in inverter mode. Why? Because if you see the statement A, average output voltage, when alpha is greater than 90 degree, average output voltage will be negative. That will give you the inverter operation. So it is mentioned that it cannot be operated. So this statement is not true. Therefore, from these 4 options, only statement B is true. So for this question, 4th option is correct, that is B only. Now let us move to the next question. Now in this question, what is mentioned, in a single phase SCR based full converter with continuous conduction operating with a firing angle alpha, what is the angle duration of conduction for each pair of SCRs in radian? Now if you recollect circuit diagram, let me draw quickly. 4 thyristors, upper half thyristors are connected in common cathode configuration, lower half thyristors are connected in common anode configuration. Therefore, this is the circuit diagram for single phase full converter. Okay. Now, if you see at any point of time, say for example, let me give you the numbers here, 1, 3, 4 and 2. So at any point of time, 2 thyristors will conduct together. That is, first and second thyristors will be one combination, third and fourth thyristors will be another combination. So if you take thyristor number 1 and 2, they will conduct from alpha to pi plus alpha. Here we are not going with circuit analysis more deeper. I hope you have basic understanding of the circuit analysis. Coming to third and fourth thyristors will be conducting from pi plus alpha to 2 pi plus alpha. Therefore, you take any one pair of thyristors, its conduction duration will be for a period of pi, and hence from these four options, option D, that is pi, that will be correct answer. Now let us move to the next question. Now in this question, in a three-phase bridge inverter operating in the square wave mode, the output voltage waveform contains, of course, basically three-phase voltage source inverter can be operated in the two conduction modes. One is 180-degree conduction, another is 120-degree conduction mode. And we have different set of waveforms, pole voltages, line voltages and phase voltages. Of course, it is not specified anything about either pole or phase voltages or 180 or 120-degree conduction. One common property of all of these waveforms, they will have odd symmetry. Okay, they will have odd symmetry. Some waveforms are square waveforms, some waveforms are quasi-square waveforms. So the property of a waveform with odd symmetry, they will have only odd harmonics. And if the question is about more deeper, like 180-degree conduction, pole voltage or line voltage, if they ask in that way, then you can go more accurate answer. But with this question statement, what I can say, they will have, because of the odd symmetry, they will have only odd harmonics. Okay, they will have only odd harmonics. Therefore, we can select option C for this question. This particular question, answer C, that is only odd harmonics. Suppose if the same question, if it is asked about 180-degree conduction mode, line voltages, they will also have odd harmonics, but in that odd harmonics, triple N harmonics, that means odd multiples of 3 harmonics will be absent. Okay, so this is the answer for the question. Next, coming to this question, what is the lower order harmonic ripple frequency of the output voltage of a three-phase fully controlled bridge converter if the AC input supply frequency is a F? Now this is one of the important question in the competitive exams. Say for example, this is N pulse converter, okay, and source side AC input and load side DC output, okay, load side DC output. So in general, source current contains Nk plus or minus 1 harmonics, where N is the number of pulses. Say for example, here it is, of course it is not asked, but in this case, three-phase full converter means output voltage will have 6 pulses, therefore N will be 6. Then lower order harmonic, or what are the harmonics contains in the source current of a 6 pulse converter will be 6k plus or minus 1. Of course, that is not the question. Output voltage contains Nk harmonics. So here the question is about a 6 pulse converter. Therefore, what is the output voltage harmonics? 6 pulse converter, then it will have 6k harmonics. Okay. Now, what is the lower order harmonic here? 6. Therefore, the input frequency is F, and hence the lower order harmonic of 6 pulse converter in the output voltage will be 6 into input frequency, that is 6 times F. Okay. Now let us move to the next question. Of course, this question is some numericals. A 200 volt 1000 RPM 100 ampere separately excited DC motor has an armature resistance of 0.1 ohm. Okay, so what I can do quickly here, at rated conditions, let us calculate back EMF first and give the suffix EB1. So how to calculate back EMF? Terminal voltage, that is rated terminal voltage, minus voltage drop across armature resistance, that is 100 multiplied with 0.1. So this is a 1 here, 200 minus 100 into 0.1. This is a 190 volt, right? Next, let us continue the question. Now this DC motor is fed from a DC to DC step down chopper. Say for example, if you draw just a schematic diagram here, this is the chopper. I can represent the chopper diagram like this. Input voltage to this chopper is some DC supply, and it is given to some DC motor. Is given to some DC motor. Okay, so this is the schematic. Therefore, what is the point of understanding here? Output voltage of the chopper circuit will be given to the terminal voltage of the DC motor. Say for example, now let me continue. The input DC source has a voltage of 300 volt to this chopper. So let me write here VDC. This VDC is given 300 volt. What is the duty cycle ratio of this chopper for motoring operation at rated torque and speed of 500 RPM? So that is important point for this question. Speed of 500 RPM, that means half rated speed. Rated speed is given 1000 RPM, 500 RPM means half of the rated speed. Assuming operation with a continuous conduction and field flux remains unchanged. Now, what we got here, this is back EMF at 1000 RPM. This is the back EMF at 1000 RPM. Okay. Now, if you calculate back EMF at 500 RPM, of course, field flux remains unchanged. When the speed reduced by half, back EMF will also reduce by half. Otherwise, you can write down the equation here. EB2 divided by EB1 is equal to N2 by N1. Then from this you will get EB2 is equal to EB1, that is 190, and N2, that is 500, N1, that is 1000. As the speed is reduced by half, back EMF will also reduced by half. That will be 95 volt. Next, what is the question here? So in order to get this back EMF, this chopper has to supply the corresponding terminal voltage, right? Therefore, under this back EMF, if I calculate what should be the required terminal voltage for this DC motor, then we will get terminal voltage EB2 plus armature resistance drop, IA multiplied with RA. So this is 95 plus, and it is also mentioned that motor is operated at rated torque. Therefore, there is no change in the armature current, and hence I can take rated armature current, that is 100 itself, into armature resistance, that is 0.1. Therefore, 95 plus 10, it will give you 105 volt, right? So that terminal voltage has to be supplied by this chopper. Therefore, I can say terminal voltage or output voltage of the chopper will be equal to terminal voltage of the DC motor. But it is mentioned that the given chopper is a step down chopper. So the expression for step down chopper is duty cycle ratio into terminal source voltage, that is VDC. This can be equated to 105 volt. So from this you can get the required duty cycle ratio 105 divided by 300, 0.35. So for this question, option A is the correct answer. Now let us look into the next question. Which of the following is the function of an RC snubber circuit connected in parallel to an SCR? So this is a very simple question. It's just based on the definition. We know that the basic function of a snubber circuit is to protect the device from sudden changes in voltages and currents. Okay, let me write down that property here. The snubber property is the basic property of snubber is to protect SCR, not only SCR, any power semiconductor device when it is operating as a switch. Now here an inductive snubber can be used to protect an SCR from sudden changes in currents. Mathematically you can also express that as a dI by dt protection. Whereas capacitive snubber will be used to protect a particular device. Now here it is a SCR, to protect the device from sudden changes in voltages or over voltages, or you can also say that dV by dt protection. Therefore, for this question, the correct answer will be option C. Now, let us look into the next question. A step-up chopper delivers an average output voltage of 100 volt from an input supply of 60 volt. So, what do you mean by this one? Here it is given that input supply voltage is 60 volt and output voltage is V0 is equal to 100 volt. V0 is equal to 100 volt. Now, as the given chopper is step up chopper, we can say the ratio will be V0 by VDC is equal to 1 by 1 minus D. V0 by VDC is equal to 1 by 1 minus D. Now, by substituting these values, we will get D is equal to 0.4. Let us look into the next question. The question is mentioned that the minimum value of anode current in an SCR that is required to sustain conduction in a thyristor with a zero gate current. See, for example, when we forward bias the device, there is one specification. When SCR is forward biased, external gate drive circuit has to supply the gate current to SCR until anode current crosses a predefined value. That predefined value is called a latching current. So once the anode current of SCR reaches to that latching current level, even if you remove the gate current, then it will maintain the conduction. So basically the question statement is nothing but the definition of latching current. Therefore, for this question the answer is latching current. Remember, in an SCR, latching current belongs to the turn on process of SCR and the holding current belongs to turn off process of SCR. Latching current is an important specification for to design a gate drive circuit. Holding current is an important specification to design a commutation circuit. Therefore, for this question the answer is option B, that is latching current. Now, let us look into the next question. Consider the following statements about three-phase voltage source inverter. Now, in this, the first statement is they require voltage bidirectional two-quadrant devices to realize the switches. This statement is wrong. Why? Because in case of voltage source inverters, we need this type of switches, that is unipolar and bidirectional switches. That means the switch need to block a voltage of one polarity, and the switch has to carry the current in both the directions. Therefore, it need unipolar and bidirectional switches. Therefore, from this point, I can say that option A is wrong. Okay, statement A is wrong. Now, the second statement, PWM techniques are used to reduce the frequency of harmonics in the output. This statement is correct. The basic purpose of PWM technique is in order to reduce the filtering size. When we can reduce the filter size, when if it is possible to eliminate lower order harmonics as much as possible in the inverter circuit, then it is possible to have filter size to be reduces. That can be achieved with the help of a PWM technique. That is one of the main objective of PWM technique. Therefore, statement B is correct. Now, let us look into statement C. In the 180-degree conduction mode, a new switch is gated in every 60-degree duration. This statement is true. So, if you look into the switching sequence of each switches in three-phase VSI, especially in 180-degree conduction mode, at every 60-degree interval, one switch is turned on and one switch is getting turned off. That is a gating pattern. Therefore, for this question, statement B and C are true. So, that is the answer. Now, let us move to the next question. Let us look into this question. A voltage source inverter is most suitable in applications where? So, this is a very standard question, and this particular question can repeat. Of course, from the previous years, every exam this question is getting repeated. So, the way how to remember this particular statement, it is mentioned that voltage source inverter. What do you mean by voltage source inverter? Input side voltage is fixed, and as per energy conversion principles, the energy stored in a voltage source can be dumped into a current stiff load. Okay. Therefore, in this source side inductance should be small, because voltage source inverter, ideally speaking, it will not have any inductance. Now, the energy stored in a voltage source can be dumped into a current sink. Therefore, in the load side, inductance to be large. Load side inductance to be large. Now, let us see the options. Source has small inductance and the load has large inductance. This is option. Option C is correct. Now, we can reframe the question. Suppose if the same question is asking, instead of voltage source inverter, if it is asking about a current source inverter. Current source inverter means source side current source can be realized by connecting large inductance in series to the voltage source. Therefore, in case of CSI, source side inductance is to be large and load side inductance to be small. Okay. So, this is a dual property between VSI and CSI. This is very, very important and popular question. Every exam this question is getting repeated. Now, let us look into the next question. There is a matching type of question is given. So, in the one category devices are given, another category its corresponding properties are given. Now, let us work out about this classification. Okay. So, let me use another color here. I will write down here. Schottky diode, basically it is a majority carrier device. Therefore, I can say this can be matched with the second option, majority carrier device. Next, silicon control rectifier, that it is nothing but a thyristor. Thyristor is a 4-layer, 3-terminal and 3-junction device. So, it is matched with 4-layer device structure. Next, IGBT is voltage control device. IGBT is a voltage control, both turn on as well as a turn off. Therefore, it is matched with 3. BJT, of course, the remaining option is 1, that is current controlled, turn on and turn off. A2, B4, C3, D1. So, option C is correct answer for this question. Now, let us look into the next question. Which among the following is an example for a voltage bidirectional 2-quadrant switch? Now, let me clarify this question here. Voltage bidirectional. So, the examiner intention is voltage has both the polarities. But in my classes, I used to follow the terminology. The standard terminology should be like this. Voltage bidirectional, I can also say that this is a bipolar switch. Bipolar switch. This is what asking in the question. Voltage bidirectional means, so generally direction can be used to represent a current, polarity used to represent a voltage. That is a standard notation. However, in this question statement is mentioned like that, which among the following is an example for a voltage bidirectional 2-quadrant switch. So, for example, if you draw the switch properties for this particular statement, it is what given like this. Voltage bidirectional. So, I can also say that it has to block voltage of both positive as well as the negative and current is of 1 quadrant. Therefore, it will give you safe operating area in first and second quadrant. In that way, it is a 2-quadrant switch. So, this type of characteristics will be exhibited by SCR. Okay. Now, let us move to the next question. Now, in this question, an ideal diode connected in series with a pure inductance is supplied from an AC voltage source. So, instead of given circuit, it is a given statement. Okay. So, from my students community, I came to know that students got confused. See, whenever this type of description is given instead of circuit diagram, first you should imagine the circuit diagram in your mind. Let me draw it. An ideal diode connected in series with the voltage source. That is a ideal AC voltage source. Okay. So, this is and a pure inductance is given as a load. This is what given circuit. It is a simple single phase half-wave rectifier, diode rectifier circuit. It is a very popular circuit also. Then for what duration in radians will the diode conduct with respect to AC voltage waveform? So, in this case, sinusoidal voltage source and a diode, inductor will store energy from 0 to pi and inductor will release that energy from pi to 2 pi. As there is no consumption element here, inductor will send back that energy to source itself. Therefore, the net conduction interval for the diode is 2 pi. For the entire cycle, diode will be in conduction. That is the answer. Now, let us look into the next question. What is the effect of AC side source inductance in SCR based phase control rectifier operating with firing angle less than 90 degree or pi by 2 radian during RL type load condition compared with the zero source impedance condition? Now, it is of course, this is also simple question only. Description is given little bit lengthy. Now, in case of single phase full converter, average output voltage is 2 Vm by pi cos alpha. At the basic discussion, we will use or we will study this formula. Now, coming to source side, inductance property. Why inductance property? For any rectified circuit, the input will be taken from the transformer circuit. So if the transformer circuit is represented as some inductive impedance, then there will be voltage reduction due to that source inductance. That reduction is expressed by this formula. So the second term in this equation is voltage reduction due to source inductance. Therefore, by considering inductance nature of the source part, what is the effect here? Average output voltage is reducing. Okay. Therefore, I can say here option C is correct answer. Now let us look into the next question. A motor load combination operating in motoring mode, that is in the first quadrant, has the following speed torque characteristics. One equation is given to represent motor torque, a second equation is given to represent load torque. Of course, here it is mentioned that motor torque and load torque, where n is the speed of the motor. Now the question is, what is the steady state speed of the system after exciting it? Steady state speed, that means the speed is reaches to particular steady value, that means there is no change in the speed. Say for example, if you write down electromechanical equation J into d omega m by dt plus b into omega m plus TL is equal to TE, right? Now, just for the simplicity, let us assume that this frictional term is 0. Therefore, when we can get steady state, let us see. From this equation, we can write d omega m by dt is equal to TE minus TL divided by J, where TE is a motor torque and TL is the load torque. Steady state speed means at steady state there is no change in the speed. In other words, d omega m by dt will be 0. This is possible when TE minus TL is equal to 0. Okay. Therefore, if you substitute this equation, what is TE here? 0.1 into n minus 10 minus TL, substitute TL, 0.25 n minus of minus plus 75 is equal to 0. Therefore, by solving this equation, we will get 65 is equal to 0.15 n, and hence n is equal to 65 divided by 0.15. This numerical value is 433.33 RPM, and hence option B is correct answer. Okay. Next, let us look into this question. Of course, this question is directly repeated question. This question was previous GATE question in GATE 2020. This question was given. Now, anyhow, let us solve it. In the DC to DC converter circuit shown, the switch Q is switched at a frequency of 10 kilohertz. Frequency is given 10 kilohertz. Therefore, one cycle time is 100 microsecond. Okay. With a duty ratio of 0.6. What do you mean by that? Switch is turned on for 60 microsecond and turn off for 40 microsecond. That is the question. all components of the circuit are ideal and the initial current in the inductor is 0. Now what we need to calculate here, energy stored in the inductor in millijoule at the end of 10 complete switching cycles is. Now if you observe the circuit carefully, inductor, suppose if the switch is turned on, inductor is connected to left hand side 50 volt source, and in that case the current will flow through the inductor in this direction. When the switch is turned off, then what happens? This inductor will release energy through second 50 volt source. In that case, now the current will flow through diode in that direction. So those are the directions of inductor currents. So let me write down simple equations here. During on period or during turn on time of the switch, what happens here, voltage across inductor, let me write down like this, L into di by dt. This is equal to 50. In other words, you can say that inductor current will increase with a slope of 50 by L. So that is a rising slope of inductor current. During turn off time, during turn off time, voltage across inductor is equal to, now it is connected to 50 volt, but what happened here, the upper plate of this inductor is connected to negative voltage of the 50 volt source. Then I can take, this is minus 50 volts. Therefore, inductor current decreasing with a slope of minus 50 by L. Now the interesting part in this question is the inductor current rising and decreasing at a same slopes. But what is the different here? Durations of this rising and falling is different. Now with this, if I draw inductor current waveform here as inductor, now y-axis inductor current, x-axis time in microsecond, right? As inductor current is starting from 0, initial inductor current is 0, okay? So I can say that this inductor current increases for a time duration of 60 microsecond. So x-axis I have already noted as a microsecond. Therefore, this interval will be 60 microsecond. At what slope this current is increasing? 50 by L. Inductor current rising slope is 50 by L. Now, when the switch is off, that is for how much duration? That duration is 40 microsecond. This duration is 40 microsecond. Now, at what slope this current will decrease? Again, the same slope. Again, the slope is the same. This is a minus 50 by L. Minus 50 by L. So, what is an important point that we need to understand? This is for one cycle, 100 microsecond, right? Now, what I can say that before starting the next cycle, whatever energy is stored in the inductor, it is not yet released. Okay, it is not yet released. Therefore, what happens? This inductor current is not reaches to 0. Then the next cycle will start from this point and it will decrease like this. So, in this way, there are 10 cycles if you plot it. So, at the 10th cycle, what happens? This current will be something like this. It will be at this point. So, if you calculate what is this inductor current at this point, that means at every cycle at what rate it is increasing, then you can find out current at this point clearly. Now, let me use this notation here. Let me take this A, B, C. So, in this case, what I can say, in triangle ABC, I can write down the slope here. 50 by L is equal to BC divided by AC. So, from this I can find BC value. What is BC value? 50 divided by inductance. Inductance is given 10 millihenry. So, this is a 10 into 10 power minus 3 into AC, where AC is 60 microsecond, 60 into 10 power minus 6. So, with that you will get that BC value is 0.3 ampere. You will get BC value is 0.3 ampere. In the similar way, say for example here, if I take another line, so this is BC. Let me take here BDE. So, in the triangle BDE, if you apply slope concept again in triangle BDE, if you apply the slope concept 50 by L, when you are writing slope concept, just you look into only magnitudes part. Then what about this value? BE divided by DE. Therefore, from this you will get BE value is equal to 0.2 ampere. 0.2 ampere. So, what is the understanding from this calculation? This height will be 0.3 minus 0.2. It will be 0.1 ampere. Okay, 0.1 ampere. What do you mean by this one? At the end of one cycle, at the end of one cycle, let me use here I1, inductor current is 0.1 ampere. That means every cycle the current will increase at an incremental value of 0.1 ampere, 0.3 minus 0.2, that will give you 0.1 ampere. In the similar way, at the end of 10 cycles, at the end of 10 cycles, let us use I10, this current will be 10 multiplied with 0.1, it will give you 1 ampere. Now, what is the question? Energy stored in the inductor in millijoule at the end of 10 cycles. Therefore, I can write energy at the end of 10 cycles half L I10 square, half into inductance value is 10 millihenry and current is 1 square. Therefore, answer is 5 millijoule. Answer is 5 millijoule, right? Now, let us look into the next question. A three-phase diode bridge rectifier supplied from a three-phase 400 volt 50 hertz delivers power to a resistive load of 50 ohm. The peak value of instantaneous load voltage would be. So, if you look into this particular circuit output voltage waveform, it will be something like this. So, like this, there are 6 pulses. Okay, there are 6 pulses. So what about this voltage here? This is a VML, right? Now we want the peak value of or peak instantaneous value of the load voltage. So what it is? This VML is equal to 400 into root 2 volt. This will be peak instantaneous load voltage. VML is equal to 400 into root 2. Okay. Now let us look into the next question. A three-phase fully controlled converter is feeding the armature of a separately excited DC motor. The motor has to also operate in third quadrant. Which of the following method is suitable? Now if you see this circuit operation, it requires third quadrant of operation. Okay. Suppose you can take V0 in the x-axis, y-axis, and I0 on the x-axis. So it need 4 quadrant of operation, right? Need 4 quadrant of operation, right? So in this now, here it is mentioned that particularly we need to operate in the third quadrant. So out of the 4 quadrant, if you need to operate in the third quadrant, what is required? Negative V0, negative I0 is required. Both terminal voltage and terminal current negative. V0 can be, you can get the negative voltage by controlling alpha, and the negative current you can get it by interchanging armature terminals. Change armature terminals. So if you see these options here, by adjusting triggering angle alpha followed by armature connection reversal, that is option C. Next question, which of the following armature voltage control methods is employed when the supply is a DC? Obviously, when the supply voltage is a DC, by using chopper circuit, we can have smooth control. Smooth voltage control is possible with the help of chopper. Now, let us look into the next question. Consider the following statements about a triac. 3 statements are given. We need to identify which statement is true. A triac is a bidirectional current carrying capability as well as bidirectional voltage blocking capability. Therefore, if you see the triac as a switch, the quadrant of operation is 4 quadrant, bipolar and bidirectional switch. Okay. Therefore, I can say first statement is correct. Second statement, statement B. A triac is functionally equivalent to 2 anti-parallel connected thyristors. Of course, that is also true. Triac circuit symbol will be like this. This is equivalent of 2 SCRs connected in anti-parallel. So statement B is also correct. Statement C. The triac can be turned on with both positive and negative gate currents. Of course, in order to turn on and turn off this triac, we can use both positive as well as negative gate current. All the given 3 statements are true with respect to triac device. Now let us look into the next question. The single phase diode bridge rectifier is used to supply highly inductive load. That means you can say that load current is constant. Highly inductive load means we can say I0 is constant. If the load current is assumed to be ripple free, of course that is what I naught constant, then the input current or the source current at the AC side of the rectifier will be. So, in this case, the source current waveform will be a square waveform. D1, D2 will conduct from 0 to pi. This is the source current. In that case, it will carry I naught. When D3, D4 are in conduction, source current will be negative, that is minus I naught. So, here D1, D2, here D3, D4. This interval is pi, this interval is a 2 pi. So, square wave is the correct answer. So, with this I can conclude this video. So, from this discussion around 21 questions came from power electronics, only power electronics, pure power electronics questions. So, this is having a good amount of weightage. Out of 150 questions, 21 into 2, 42 marks came from only power electronics. So, I will take another video to explain the solutions of control systems from the same exam. With this, thank you and I wish you all the best everyone.